Question 7. Two balls, X and Y, are dropped from a very tall building. Both balls reach terminal velocity before hitting the ground. The balls have the same diameter. The mass of X is greater than the mass of Y. And we've got to work out which statement is correct. Okay, in order to do this, we need to think about what we know about terminal velocity, and how our object gets to terminal velocity. So I'm just going to draw myself a velocity time graph, and let's do that up here. Okay, so we're going to have a look at how the velocity is changing with time. Now, what will happen is our object will fall. Initially, it will accelerate at g, so 9.81 meters per second squared, and then as it gets faster and faster, the drag force gets bigger, so the rate of change of velocity gets smaller until we get to our terminal velocity. And when our object is at terminal velocity, we know that the weight of the object, mg, is going to equal the drag force. Now, and the other point we need to realise, which I did just mention, is right at the beginning, when the drag force is 0, then the acceleration is g. So both of our objects, regardless of the mass, because of course you should all know that everything falls at the same rate in a vacuum under a gravitational field. So if I just change my pen colour, let's say that black one was X, and then what we'll do is we'll now draw in for Y. So again, Y will accelerate at the same rate to begin with, but as it gets faster, the drag force will be the same for every speed because both the balls have got the same diameter, but it will tail off sooner because it doesn't have to accelerate for as long to get to a velocity or a speed where the drag force is equal to its weight. So we have got that. So my blue line here is for Y, my black line is for X. And now let's have a look at the statements and we can work out which is correct. The balls hit the ground at the same time. That's not going to be true, because on a velocity time graph, it's the area underneath the graph which is equal to the displacement. So because X is going to be travelling faster than Y, X, and hence the line is above the line of Y, in order to get the area to travel the distance down to the ground, it will do that in a shorter amount of time, whereas Y's area is spread out over a longer time. So A is not true. Let's have a look at B. The terminal velocity of Y is greater than that of X. That can't be true because Y has to be doesn't have to travel as fast in order to get the drag force to equal its weight. The initial acceleration of both balls is the same. That one is correct. And then we'll just have a look at why the last one can't be true. The two balls have the same kinetic energy just before hitting the ground. Well, that can't be true because they have different masses and they will be travelling at a different velocity. So Y has got a lower velocity and a lower mass, so its kinetic energy will be lower. If we just make sure, just to reiterate why C is true, the initial acceleration of both balls is the same. That's because initially, right at the very beginning, the drag force is 0, so both balls will have an acceleration of g, which would be 9.81 meters per second squared. So my answer is C.